Today we do the alcohol, chapter on alcohol. The general formula, this is the functional group. OH is the functional group, hydroxy group. Alcohols are hydroxy derivatives of aliphatic hydrocarbons, and phenols are the hydroxy derivatives of aromatic hydrocarbon. That means they have a aromatic ring. OH group is directly attached to the, this is phenol, and alcohol CH3, CH2, OH. This is alcohol. Now classification of alcohol, we'll do phenols later on. Today classification of alcohol, classification. Depending on the number of hydroxy. One general is what? Aliphatic and aromatic. This way we can classify aliphatic alcohols, that is ethyl alcohol, propyl alcohol, all these. And the other is aromatic alcohol, where it may be directly connected to OH, or it can be to the benzene ring, CH2OH, this way, benzene alcohol. Thank you. The other method of classification, this is one, aromatic and aliphatic alcohols. Depending on the number of hydroxy groups, one hydroxy group, monohydric, two hydroxy groups are present, dihydric, three hydroxy groups are present, trihydric alcohol. So monohydric alcohol, CH3OH, CH3, CH2OH, these are all monohydric alcohol. And phenol, in aromatic ring is attached, then it is called a phenol. Then dihydric. Dihydric, where two OH groups, this is methanol, this is ethanol, now two OH groups, CH2OH, CH2OH. Ethane 1,2 diol, this is ethane 1,2, carbon number 1, carbon number 2, diol. This is the dihydric alcohol. It's also called glycol. In common naming system, it's called a glycol. Similarly, here also to the ring, two OH may be connected. Now the OH, the two hydroxy groups can be at different places. One at ortho position, or it can also be, this is quinol, this is catechol, this is resorcinol. Catechol, resorcinol, quinol. Trihydric alcohol. CH2OH, CHOH, CH2OH. Propane 1,2,3 triol. Propane 1,2,3 triol. Three OH groups are there, so trihydric. OH, OH. This is pyragalol. Pyragalol is what you use for testing oxygen, presence of oxygen. Oxygen when passed through, alkaline pyragalol gives a brown color, changes it to brown. It's white in its color, it's colorless, then changes to brown in presence of oxygen. So trihydric alcohol. Maybe polyhydric also. Polyhydric, CH2OH, CHOH 4 times. Means CHOH, CHOH, CHOH and another CHOH. 4 times CHOH, and then again CH2OH. This is sorbitol, 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 mannitol. Now monohydric alcohols can be further classified into primary, secondary and tertiary alcohols. Let's see that. If the OH group is connected to a primary carbon, then it is called a primary alcohol. Means CH3 monohydric primary, we write it like this, primary alcohol, like CH3 CH2 CH2 OH. Means the hydroxy group is directly connected to a carbon which is connected to one carbon only. That is, it is a primary carbon atom it is connected to. So it is a primary alcohol. Secondary alcohol. Secondary alcohol is like CH3 CH CH3. See, the same molecular formula is same. These are isomers. So CH3 CHOH CH3. This is attached, this OH is attached to a carbon atom which is in the ring, in the chain. That is, it's a secondary carbon atom. This carbon to which OH functional group is attached, it is further connected to two more carbon atoms. So this is secondary carbon. OH attached to the secondary. This is now the very in thing, isopropyl alcohol used in your sanitizers. So this is isopropyl alcohol or propane 2-ol. Propane 2-ol. IUPAC name is propane 2-ol. Tertiary alcohol. When the OH group is attached to a carbon which is tertiary in nature, means CH3C, this hydrogen also, in place of that also there is a CH3 group. So this is tertiary alcohol. This is the classification. Now isomerism. What are the isomers of alcohol? It exhibits chain isomerism, functional isomerism, position isomerism and optical isomerism. First we will see chain isomerism. This is the normal straight chain isomer, CH3, CH2, CH2, CH2OH, that is 1, 2, 3, 4, butanol. Now the isomer of this. One, two, three, four OH. This is also the same molecular formula, but you can see the chain has, this is a straight chain, this is a branched chain, this is a branched chain, right? So this is in IUPAC system, what is the name of this? This is propanol, 1, 2, 3 propanol, but on 2 position there is a methyl group, C1, C2. So 2 methyl propane, 1-ol or propanol, but this is just butanol. Now this is chain isomerism, straight chain and branched chain. Second is position isomerism. Position isomerism is like what? See this. CH3, CH2, CH2, OH. This is propanol, and if the position of the OH group, the position here, the position of CH3 only is changing, but if the position of the OH group changes, functional group changes its position, then it called a position isomerism. See, isomerism is CH3, CH, OH, that isopropyl alcohol, just now we were discussing this. So CH3, CH2, CH2, OH and CH3, CH, CH3, OH changes the position to the secondary carbon. That means it is these two are position. This is propane 2-ol and or isopropyl alcohol, and this is simple propanol. This is a straight chain. This functional group is terminal over here. Functional group is on the secondary carbon. So this is a secondary alcohol. This is a primary alcohol. The primary and secondary alcohol, and examples of position isomerism. Third, there's functional group changes. Functional isomerism. Say ethanol, CH3, CH2, OH. Can be also C2H5OH. This is an alcohol. This means alcohols and ethers are functional isomers. Alcohol CH3, OCH3. This is an ether. The functional group is different. So functional isomerism also is exhibited by alcohols and ethers. Right. Then the fourth, optical isomers. How does optical isomerism, you see? CH3, CH, OH, C2H5. This is butanol, butane 2-ol. This is butane 2-ol. 1, 2, 3, 4. So 4 the carbon atoms means butane, and on 2 position this is C1. This is closer from this side, so C1, C2. So butane 2-ol will show optical isomerism. This is the asymmetric carbon atom. Similarly, even if it is pentane 2-ol, then also it will show, because see, all the 4 groups attached to this carbon are different. That is CH3 methyl, ethyl, hydrogen, hydroxyl. So it will show optical isomerism. It will show optical isomerism. Now we will do preparation